Hi there, this is Azul Maksud. I am with a very high level project here today. This is also job ready high level project. Mastering 3-tier architecture with EKS, CloudFormation and monitoring. This is a complete deployment guide. So EKS with CloudFormation and also monitoring Prometheus and Grafana I will show you. So this is really super. If you add this one in your resume, just awesome. So project roadmap is like that here. Create an EC2 server first. I'll do that. Bastion server. Then install and configure AWS CLI in the EC2 server. Then install EKSCTL and kubectl. Then create a cluster using EKSCTL. Install Helm. Install MySQL using Helm and mount EBS volume. Configure the MySQL database. Build the 2-tier application version 2 or version 3 with database backend. So first I will build the application with backend, then push the Docker image into the Docker Hub, then build the 2-tier application v2 for the front end. So one for front end, one for backend. Okay, then push the Docker image into the Docker Hub. Then I will create a deployment and service for the backend in the Kubernetes cluster. Then create a deployment and service for the front end. So one for backend, one for front end. View the application running or not. Incorporate Prometheus and Grafana in this stack for logging and monitoring. That one will be last. So front end, backend, that means 2-tier, right? 2-tier application. And 3-tier, how come? So MySQL makes it 3-tier. Okay. Yes, first of all, let's create a Bastion host. E2 micro is more than enough. I have the key pair already, and VPC is okay for me. Default one. I'm using the default security group. It has everything there. Okay. So I have to take the public IP from Bastion. It's running, but initializing still. I'm using mobile XTM here. Session, SSH, Control V, username, Ubuntu, advanced, private key. I will use the private key, default PAM. Yeah, it's coming. So full upgrade is needed. Yes, it's done. So I have to paste something for the CLI, AWS CLI, EKSCTL, kubectl. So I have taken everything in the paste repo. If you come to my GitHub, you can take from here. So paste repo, this one AWS CLI, kubectl. So everything is here. I need from here first unzip, then yes, I need everything from here. So already I did the upgrade. So see here, first unzip, then CLI installation, then kubectl installation, EKSCTL installation. Yes, it's done. Now I have to do AWS configure. So for this reason, I need access key, secret access key. I find this one in the IAM, Identity Access Management. Where's IAM here? Yeah. I have to create a one user. So I'm using one user for you guys today. EKS user. Attach policy. So I'm giving the administrative access from here. Next, create user. So this is created EKS user. I need security credential, that means access key, right? So it's for AWS CLI. CLI is this one. This is the CLI. So for this one, I have to understand. Next, get access key. So in the real time, you have to save this one .csv file. But after this demo, I'll just delete this one. Okay, I'm copying from here. Okay, then secret access key, copying from here. Then region US East 1. Output format JSON. Okay, so AWS S3 LS. Yes, I have these buckets, so it's working now. Good. Yes, now let's see the version. kubectl version first. This is the version here, v131 point something. Then EKS also version I have to see, because before jumping to the real one, I have to see everything. EKS version. EKS is 0.197. Okay, sometimes if you are applying for the senior level DevOps, maybe asking which version you are using. So just keep in mind, if you are applying for senior level DevOps, that your latest EKS version, which one, please keep in mind. And also keep in mind the kubectl version. v1 it starts with, then now 31 something. So EKS starts with 0 point, then 197, like that. Now I have to create a cluster. EKS using the EKS I have to create the cluster. So for this reason, I have to edit cluster config. So how can I do that? Nano cluster.yml. Then I'm inserting this one, API version EKS because I'm using the EKS .io. Then slash something, no need to memorize. Kind is cluster config. This is important. Metadata, I'm giving the name like December 24 EKS, region US East 1, node group. So metadata, under the metadata, then it has come name region, then node group ng1, instance type T2 medium. I'm giving desired capacity just 2. So see here at the left, this API version, kind, metadata, node group, these 4 guys in the same alignment, right? So YAML file alignment is very much important. Okay, so these 4 guys, at least these 4 guys needed for EKS using the cluster to create the cluster. So this is Control O. I'm good. So Control X for nano. After doing this, I have to do EKS create cluster -f, that means file. We have created this one, right? So it's started. It will take 15 minutes. I'm coming after 15 minutes. Yes guys, so it's saying that EKS cluster December 24 EKS for US East 1 is now ready. Okay, Control L. So let's see now EKS this cluster, kubectl get node or nodes, either way. So it's showing that 2 nodes are created, internal version also given here. Let's see here first in the stack, because we have used the CloudFormation. Stack has created 2 stacks here. First one for the cluster, second one for node group stacks. And for the cluster, this is the December 24 EKS. We have given this into the metadata, the name, right? This active, and version is 130. Okay, so here overview is here. I can see the details: API server, endpoint, certificate, authority, open ID connect provider, then identity access management, role ARN, cluster ARN is here. Then everything is showing which one is given here. But to me important is add-ons. Okay, kubeproxy is active for networking. Kubeproxy working with the worker node, then VPC CNI is active, then core DNS networking. So this is also interview question for the cluster networking. How many things are needed for the add-ons? 1, 2, 3. kubeproxy for worker node, then VPC CNI for Amazon, then core DNS, so for internal. So core DNS, CNI, VPC CNI, and kubeproxy. These three guys are needed. And let's see our nodes. Here is 2 nodes, right, are created. Both are internal. Okay, then for these nodes, these are created with auto scaling group. So this is the auto scaling group. Here is the instances 2, desired capacity 2, minimum 2, max 2. So these are the details of the auto scaling group. Okay, see here we did not call the auto scaling group, we just call that. Let's see our this file, cat cluster.yaml. We called which one? Node group. Desired capacity is 2. We called desired capacity. We did not call a auto scaling group, but it has used the auto scaling group. So when coming the question like that, you can add everything that auto scaling group I have used like that way. Without calling auto scaling group can be created also. Now I have to do alias first, because every time kubectl writing is really killing the time. So for this reason I'm making nano. Okay, I do also beam now. Nars, then tilde, then slash, then dot bash rc. Yes, so inside insert mode for anywhere I can put some my alias I created, alias k equal kubectl kgp kubectl get ports, kgs kubectl get service, sbc that means service, ask I'm good with this one, wq. So this bash rc I have to give the path source, I have to see the source path. Okay, so now it will be working. We can see here kget, right, kget node, kubectl get nodes we have given, so we can use here kjust. We can see the same thing here, right, it was kubectl get node, here it is just kget node, it's working. We can see also our kgp kget port, but namespace is kube system. I can see by default like that way, because pod needs the namespace. So in the kube system namespace it has node 1, 2, so it's running 2 by 2. Core DNS, we saw the core DNS, right, the networking, core DNS to kubeproxy. So this is the pod also. Where is the core DNS we saw? I'm showing you. This is this one. Let's see here in the EKS. It has the core DNS. The add-on. See here, core DNS, kubeproxy, and VPC CNI is with Amazon. So core DNS and kubeproxy both are here working as the port. See KGP default port. Which one? Default kube system. We can see also the namespace. How many namespace here? K get ns namespace. So here the default namespace, kube system, kube public, like that way. We can see here kgp -n default namespace. We are doing something discovery. There is nothing in the default. Now I have to install MySQL using Helm. For this reason I have to install Helm first. So here is the helm.sh docs intro install. I'm using the Ubuntu Debian. So yeah, I have to copy this one from here. Just paste. It should be installed. Yes guys, this is installed. So then I have to add repo, Helm repo, add bitnami chart. This is charts.bitnami.com/bitnami. So Helm is the package manager. It works upon the chart. It needs the chart. So yes, this is done. Happy helming. Also the list is showing here. Also update is done. Now I need to install EBS CSI driver as an Amazon EKS add-on. So for this CSI driver, here is the, I think which one? Yes, see here, Amazon EBS. So for the EBS CSI driver, you can follow this documentation from here. I am following also here this documentation. So first of all, I have to export the cluster name here, December 24 EKS. So YDC I have to use here, YDC ID is here. So everything looks good. AWS IAM list, open ID connect, that means YDC provider, grep echo YDC ID. So EKS util associate provider cluster December 24 EKS. It should be approved. Yes, our YDC connector is done. We have got also the number here. Now we have to do we have to create IAM service account. Should be approved. It's creating. Yes guys, so IAM service account is created. Now I have to create add-on, EKS CTL create add-on, name AWS EBS CSI driver, cluster is today's December 24 EKS, then service account role ARN. So yeah, it's coming like this way, but I have to change here my ARN, the name. So role ARN I have to take from my account. This is the IAM, this is the role. So this one is created, EBS CSI driver. Okay, so this one, the ARN, I have to copy this one, Control C. Okay, then right click. Okay, so yeah, role Amazon EKS CSI driver role -- force. Okay, it's now done. So let's see in our cluster. It has earlier add-on. How many add-ons? Add-on was 3, right? Earlier CNI, DNS, core DNS, proxy. So it should be now more add-ons. Let's see here. See here, now 4. That means CSI driver, this is still creating. Yes guys, so Amazon EBS CSI driver is now active showing. So here is now 4 add-ons: VPC, CNI, core DNS, EBS CSI driver, and kubeproxy. Okay, let's see here. This is done. Control L, KGP. Let's see the pod -n namespace kube system. We have the pod there. Yes, EBS CSI driver. How many pods? 1, 2, 3, 4. Oh my goodness, see here. 1, 2, 3, 4 showing, and here is see all are running. So all the pods are showing here. So before installing MySQL, I have to add some more storage. MySQL needs storage. My goodness, too much storage is needed. So I'm doing nano storage.yaml. Yes, I'm pasting this one. API version storage dot kubernetes.io/v1 kind is storage class. So storage class I need some. For metadata, name EBS SC annotation. Here is storage class dot kubernetes.io is default class, true annotation. Then provisioner EBS.csi aws.com parameters, type gp2 storage, reclaim policy, retain volume binding mode, wait for first consumer. Okay, control O, enter, then control X. So this is done. So now I have to edit MySQL values.yaml also. Before creating the MySQL database, I have to have a YAML file. So I'm using nano MySQL -values .yaml. Okay, I'm adding this auth and primary. Under the auth, there is the root password hello 123. I have given create database true, that means authentication. Then database 2-tier I have given here, and username 2-tier user, password secret pass. You can change anything else. Primary persistence enable true, storage class EBS-SC, access mode read write once, and size 20 GB. Okay, so control O, enter, control X. This is done from here. Now using the Helm, I have to do that. So using the Helm, already I have installed the Helm, right? Now control L, ls. I have to see how many files are here. Cluster MySQL values storage.yaml. So this is the command helm install MySQL OCI registry1 docker .io bitnami chart /MySQL. So MySQL will call from this location. -n, that means namespace should be MySQL, and create namespace, that is the tag, then space -f, the file MySQL values.yaml, that means this one. From this file it will be created. So Helm will create, that means install Helm. Yes guys, so it looks done. Namespace MySQL should be. So let's see the KGP, control L, KGP -n namespace, then MySQL. Yes guys, MySQL running. It's a really great achievement, because lots of times problem MySQL not running. So let's go inside this pod, kubectl exec -n MySQL namespace -it. Then this is the MySQL pod name, then space -- space bash. Okay, we are now inside there. So how to do signing MySQL -u, user is root, -p, password. Our password was hello 123. Oh, my bad. It's good now. Okay, so show databases first. Always you have to see databases. We have the 2-tier here inside. So use 2-tier. Okay, database is changed. So here inside I am creating the table for user and history. These 2 tables I'm copying first, then just create table users, then ID int. So everything is here, I'm not going through. So create table history and users, these 2 guys. Show tables history and users is here. Then I have to insert something, email password. I'm making something quicker. So insert into users email password values like this way. And GitHub 2-tier app, this repo I'm just making clone https. So git clone this one. Yes, ls is 2-tier app, we have to go there, cd 2-tier app, ls inside backend and front end. So first of all, let's do git pull already up to date. Okay, so I have to go to backend first. ls backend has app.py requirement.txt. So also something hidden file here. I have to see .env file has. So I have to edit that .env file. I'm doing nano .env. So here I have to delete everything, then I have to add something changed. Okay, so yeah, just deleting first, making simple everything. Yes, so MySQL host, I'm giving the name this one, mysql.mysql.svc.cluster.local, then 2-tier user, then secret pass, then 2-tier. So host name, then user, then password, then database. Host, database, user, password, these 4 things. MySQL. So Control O, enter, Control X. This is done. Now I have to install Docker. So I'm taking this one here, sudo apt install docker.io-y. This is the basic thing. Yes, Docker is installed. So Control L I have to do. Now Docker login. So sudo docker login. Username is Azizul to go. Okay, password I'm giving. Yeah, I succeed. So I have connected this one so the username Azizul to go. This one is here. So this is my GitHub. Now I have to edit Docker file. That means I'm doing nano Docker file. Okay, right click. So Docker file here from Python workdir app, then run apt-get update y and apt-get install python 3 pip python 3 deb, then lib. Everything is here, I'm not going through. Okay, then it will be removed, this location, everything. Then it will be copied. The run pip install requirement.txt. I have here expose 5000, then cmd, the flask run host this way. Okay, this is the Docker one. Control O, enter, Control X. Docker file is down like this way. And now I have to do Docker build. Control L. How many files are here inside? Docker file app.py, then requirement.txt. Let's see one more time. Docker file. So Docker file is calling this app. See here, work directory app. It will call this one. From here inside it will run this update, everything it will run. Okay, then run pip install -r, then requirements.txt. It will run after that. So app.py and requirements.txt is very much important here. So using everything, now sudo docker build -t, tag also giving. So username first, Azizul to go. Azizul to go. Is it good? Azizul to go. Okay. Slash, I'm giving the name like full stack. This way. Full stack app. Then colon, I'm giving the version like v1, like this way. Then space dot. This is very much important. because it will call everything in this directory now. So I'm creating full stack backend first, backend, then colon b1, then everything from here. It has created successfully full stack backend. So I have to push now. So just I'm pushing docker sudo docker push hyphen t. Actually no need here now because this is built up now. Just docker push, then everything is here as usual to go. Backend one I'm pushing. It looks pushed done. So let's refresh here. See here, as usual to go full stack backend, less than 1 minute. This is here and version 1. Okay, looks good. Now let's go to the front end. cd, step back, cd front end ls. So front end has default.conf, package.log.json, then package.json public src yarn.log. So I have to edit one more docker file here, that means nano, then docker file. I'm inserting these guys from node, front end from node, backend was python, right? So front end from node, then run apk add update this way slash, that means next line, python make g++, copy everything from src folder, then workd src. So this is the src workd showing, copy package everything, start, run npm install, run yarn build from nginx latest, run then run first is removing everything from here, actually HTML removing first, then make did HTML there, then copy from build stage, then it's going this one when removed, then this is just copying everything src build, then copy default.conf, then it will be just moved there, expose ad. Okay, so control O, then control X. So our docker file for front end also done. Yes, now ls I have to edit default configuration. So nano default.conf, here I have to edit here, I have to add here proxy pass http colon dash dash, then it should be backend spc, backend service is connecting with backend like this, sbc service colon 5000 is the backend port. So same way, location summation proxy pass should be same thing, http like this way, backend hyphen sbc colon 5000. So we have to add with location and reverser and summation, we have to add login and get history. Okay, so here let's come location, it should be login, then it should be get history, Okay, Control O, enter, Control X. Now I have to create actually edit then .env file for front end also. So make sure this backend API URL should be blank. So it's good now. So Control X, nothing changed here. Now I'm ready with to build the front end image. Sudo docker build -t, that means tag. So this will to go is the username, then full stack. This is front end, right? Full stack front end :v1 space dot. So everything looks good. So the docker build like this way, full stack front end. Okay, it looks good. Yes guys, so build is done. Control L. So I have to do push, right? Docker sudo docker push, no need tag, no need build, just push front end, full stack front end. Okay, it's mounted first, boost mounted, looks done. Okay, let's do here. Yes, this is the front end, backend front end, less than a minute. Okay, let's go there. Full stack front end as well to go. This is done. Okay, it's good. Now I have to create backend deployment first. Control L. Let's go to the home directory. Control L, ls. These guys are older one. So this is the command for backend. Kubectl create deployment backend -image. So image name should be changed. Image name I have given full stack -backend. So image name is full stack -backend version 1. So output is here YAML dry run client in 2 tiers. So this is the backend deployment. So I have to create first 2 tiers, namespace kubectl create ns 2 tiers. Okay, it's created. Now I can use this one, kubectl create. I can use this one because here namespace is 2 tier I have given. It's created. ls. So backend.yaml is created. Yes, now I have to apply. After creating everything we have to apply, right? Okay, apply -f, which one? Backend.yaml. Oh, it's created, deployed. It's good. So after that, let's see the pod kgp. Yes, so kgp kubectl get pod -n 2 tier. So our this backend pod is running. Now I have to expose this backend for our service to get the service. So here kubectl expose deployment backend, name backend sbc, backend service, and then -, type node port, then port like this way 5000, client this way. So it will be exposed in the 5000 node port. Okay, 2 tier is the name space. Okay, it's done. Backend service is good. This is the service kind. Everything looks good. So after having the service, I have to copy from API version here. Okay, Control C. Now I have to edit, that means nano backend.yaml. So here I have to add separator 3, then just I have to add this one is service and first one is deployment. Two types of kinds is here. Okay, then Control O, enter, Control X. Yes, so now this is the apply -f backend. This is created. Then this is the KGP, the pod, then pod is running here. Then KGS, kubectl get service also, this is running here. Now I have to create front-end deployment. Just I am doing this one for front-end deployment. Control L, deployment is done. Then I have to apply, right? Okay, apply -f frontend.yaml. Yes, it's done. Now let's see KGP 2-tier is showing that node port, this one. This is the KGS, KGP. See the front end also running. So I have to now expose the front end one to have the service. Expose. Same way I have to take this API version to load balancer, everything. Control C. Now nano frontend.yaml. I have to add after everything separator, this one. Control O, Control X. So nano is done from now. So now I have to apply front end. This is applied. So KGP hyphen and 2-tier, right? 2-tier. Yes, both guys are running. Also, let's take the KGS service from here. This is the front end service. Also 31,253 is the node port is here, front end node port. So now we have to see that our front end node port is running or not. Let's go. So take one from here, node security. Come to the security, any one security group, come here. First of all, edit inbound rule, add all traffic. Where is all traffic? All traffic, IPv4, save rules. So go back there, instances. It was first one. Take the public IP, come here, colon, then I have to take this one, 31, this one. Okay, just passed. Yes, our application has come. Yes, front end back end is also connected. Yes guys, now time for monitoring. So Control L. We have to create first, create namespace. I'm giving the monitoring. Okay. Yes guys, it looks container creating for Prometheus alert manager and Prometheus server, this number. Others all are already running. Let's try one more time. Yes, is ready and running. Yes, then it should be a load balancer for Prometheus. So this is the DNS number. Let's try this one. Yes, man, feeling good. It's so tough, man. If not coming everything all together, it's really tough. So we can see also service from here. Get ports instead of ports, SBC. Oh, my bad. Get at SBC. So here service has been given. See the number 817. It should be here. See 817. See here 817. That means this number, DNS number, we got from the service also. If we take from here, then also it's working. Sometimes if you don't see in the load balancer, application load balancer, you should come here like this way. Yes guys, Control L. Now this is the time for Grafana. Same way Grafana I have to add in the Helm. So this is the command, Helm repo add Grafana. This is the location, then update. It's coming. Yeah, it's good now. Happy helming. Now I have to install Helm using the shell, right? Today no more YAML files. So this is Helm install Grafana, Grafana / that means next line namespace monitoring, set admin password equal admin123, set service.type load balancer. So load balancer also will get one more from here. Okay, it looks good. So let's see the service for monitoring. We will get the Grafana one also. Earlier was 817 for Prometheus. This is 072 for Grafana. Let's see our pods. Pod same. So Prometheus has lots of pods, but Grafana is just one pod. Grafana is a dashboard, you know. So why Prometheus has lots of pods? Because Prometheus actually works as the database of Grafana. Prometheus is storing all the collected data inside Prometheus, and Grafana just taking from the Prometheus. Okay, we can take from here also for Grafana, but let's see the load balancer. That's good also. Load balancer. Here is two load balancers. So this is the new one. Okay, let's go there. This is the DNS number. Load balancer DNS number. Oh man, Grafana has come. So username is admin. Password we have given admin123 when you create it, right? Yes, never. Oh la la, man, Grafana has come. So login to Grafana is done. Now add the data source. So configuration first. So this is the data source. Okay, select Prometheus. Data source is Prometheus. This is the interview question, man. Please keep in mind that add data source. Data source I am connecting with a Prometheus. So without connecting, it's not working. Now the Prometheus service URL. What is the service URL? Prometheus service URL. This is the Prometheus service URL, right? You can take from here, or if you have any confusion, just go here Prometheus. This is the service URL. Okay, Control C, you can go like that way, or paste this one, because that one has the query also. Okay, this is the Prometheus service URL. Now I'm going to URL start with HTTP, right? HTTP://. Okay, so HTTP headers, everything looks good. Authentication, advanced setting. Okay, everything making same. Save and test. Successfully queries the. Next, you can start a visualize data building dashboard by querying. Okay, building dashboard. Yes, so here data source is Prometheus and query option is like that. You can add any query, and here is metrics. We can take the metrics, which one we can take. Lots of metrics are here, so we can take one metric, anyone. Then we can query the label, instance, job, result. Either way you can give there. Enter the value. Okay, like this way, run query. So query running, you can see like this way the query has come here. Same way you can change metric explorer, aggregation. First of all, see the aggregation here, select, run query. So when query is running, then it's coming the exact query. This is called Prom-QL. Okay guys, so this is the final demo for this project. Hopefully it will be helpful for you guys, but you have to do hands-on lots of, and you can get this one in my repository, DevOps 0 to Hero. You can get it here, so I'll give you the link. Okay, so you can see everything is there. Thank you very much. Have a good day.